Okay, so to write an inverse function, it's not that hard. You just want to follow a set of steps. The first step is to just take this. It's not totally necessary, but it would be much easier for you if you just take this out of function notation and write it in an xy notation. So instead of writing f of x, I'll write y equals negative 7/5 of x minus 42. All right, so an inverse function is really just the function where x and y are in opposite places, and then we'll go from there. So we'll switch x and y. So instead of writing y, I'll write x is equal to negative 7/5 y minus 42. Not so bad. And your next step is going to be solving the literal equation for y. And so for some of you, this will be the hardest part, but you have to get good at this because this is all of algebra, really. So to solve, the first thing I want to do to isolate y is add 42 to both sides. So I end up with x plus 42 equals negative 7/5 of y. And the next thing I want to do is multiply by the reciprocal of negative 7/5 to isolate y. So multiply by negative 5/7 on both sides. Remember, I need to distribute it when I do it on the other side, on the left. So I have negative 5/7. And the first thing I will do is just clean this up. So negative 5/7 times negative 7/5, that multiplies to give me 1. I have just y on this side. Then if I distribute it on this side, negative 5/7x is just that. And then negative 5/7 times 42, I know that's going to give me a negative number. 42 divided by 7, easiest way to go about doing this, it's going to be 6 times 5 is 30, and that's equal to y. And then finally, I should just use the symmetric property to rewrite it in with the y on the left. So y equals negative 5/7 of x minus 30. And this should be my inverse function. So what we want to do is we want to go ahead and actually check to see if this works. That's step 4. So I have y equals negative 5/7x minus 30. And what I should do is just take my two functions and compose them. So I have y equals, my new function is y equals negative 5/7x minus 30. And my old function was y equals negative 7/5 minus 42. So you can still compose functions even though it's not in function notation. You just take 7/5x. Oops. Just take one function and plug it in for the x in the other one. So let's go ahead and do that. I'm going to compose. Yeah. I'm going to take this function down here and plug it in for x in the function above it. So I have negative 5/7. I'll leave a big open set of parentheses. And then minus 30. And inside of that, I have negative 7/5x. And then, of course, minus 42. I'm going to have to distribute this negative 5/7 on the outside of those parentheses. So first off, it's going to multiply with negative 7/5x and just give me x. Negative 5/7 times negative 42, well, that's going to be positive. 42 divided by 7 is 6, times 5 is going to be 30. and I have minus 30 on the outside. And when I combine like terms, all I'm left with is x. So that works. And the last thing I want to do is take my, because now I'm positive that this is the inverse function. I want to take my inverse function, which is y equals negative 5 over 7 x minus 30, and I want to rewrite it and put it in inverse function notation. Function notation would be f of x, but I know that this is the inverse of the function I defined as f, so I'm going to call it f inverse of x equals negative 5 over 7x minus 30. And I am done. So there are 4 more practice problems. I'm sure you'll have questions, so if you're doing this in class, you can raise your hand. If you're not, you should definitely write those questions down and bring them to us.